Hey guys, it's Miss Wesley. This is Parabolas Day 2 on page 34 of your Conics Sections Packet 1. As you can actually see me now because I'm trying a new program to make these videos for you guys. And so if you want to just bear with me as I play around with the features of it, I will try to make this as easy to follow for you as possible. So I'm pumped to get into some actual parabolas questions here because the other day we kind of just got the basic notes about features of a parabola, and you see them all listed here. You're going to be looking for things like the vertex, the focus, right? Every parabola opens toward its focus, and the directrix is the same distance away from the vertex, just in the opposite direction of the way that the parabola is pointed. And every parabola has an axis of symmetry that goes through the important points, the vertex, the focus, and it falls perpendicular to the directrix. So let's look at number 1. And I wonder if you could just look at the equation and tell which way it's going to open, up, down, left, or right. And I see an x that's squared there. And while this is kind of contrary to what we talked about with the other conic sections, usually when the focus or when our attention is put on x, we're thinking more of a horizontal orientation, but not so with parabolas. When the squared variable is the x, think of your classic y equals x squared, right? That's a parabola that opens up for the parent graph versus something like number 2 that's going to open sideways. It won't be a function. It's going to open left or right. But I say up is the right direction for number 1. Let's see if I can draw a little sketch here. So I think this is going to be a parabola. Can I get a pen here? I think this will be a parabola. Nice blue color, that opens up because I see that not only is x being squared, but this number here is really important too. In standard form, 4p falls right in front of the other side of the equation that's not squared, being GCF'd out. So 16 equals 4p. And this will come in handy later to know that p equals 4. We'll just let that sit there so we can use it for some other stuff later. So I want to write out a couple of the points. Let's write what the vertex is. So the vertex is at h comma k. We'll put it at 0, 4. And I'll put that right on the graph in red here. And the focus should be p units in the positive direction. Since the focal length is a directed distance, we're going to go 4 units up from the focus, so to 0, 8. And we'll plot the focus. And you can actually plot a little rough sketch of the parabola now. This is the part I'm nervous about because my handwriting's not so good on this program, but I'm sure yours will look better than mine. Please don't laugh. Next up is the directrix, and we know that the directrix is the same distance away from the vertex as the focus was, just in the opposite direction. So we want to take it down 4 units to y equals 0. That is overlapping the x-axis, and we can draw it as a horizontal line. Nice, that overlaps the x-axis. I will put arrows on the end of it too, right? And that's your directrix. Now's the time to sketch it. I guess we could put the axis of symmetry on there too. It's easy to get the axis of symmetry if you have the points lined up like this. We've talked about how the axis of symmetry visually goes right through the focus and the vertex. And look for the shared coordinate. Both of these have the x coordinate of 0, so your equation has got to be x equals 0. For the axis of symmetry. Now this is supposed to be a dotted line. There's probably a tool for this. This is not going to look that great. See what I mean? Have this go straight up the axis. Make yours look better than mine. And you have the axis of symmetry. The parabola is the exact same mirror image right and left of that. And now the scary part. Remember, please don't judge. Hopefully yours looks better than mine. You've got a parabola that opens up toward that focus. And again, who am I to judge the artistic quality of your parabola if mine's going to look like this? You're just graphing a rough sketch and make it generally look like it's the right shape and opens the right way. Remember what the focus does. The focus, when it's pulled far away from the vertex, it's going to make for a wider parabola. And when it's closer in, if you ever have a focus that's really close to the vertex, maybe just draw your parabola so that it looks a little bit skinnier. But we're going to leave that one there for now and take a look at number 2. I want you to look at it and decide for yourself, just looking at the standard form equation, does it open up, down, left, or right? And I'm hoping you're picking either left or right because you see that y is squared. That'll determine whether it's sideways or up and down. And this guy, the negative 20, should determine that it opens down, right? You have a negative 4p value. So if 4p equals 20, I guess p is supposed to equal negative 5 here. And that tells me this thing opens in the negative direction. We're going to place the vertex and have it open left from there. So speaking of the vertex, let's write the coordinates. Look for h and k. So how about 3, -2? X minus h, y minus k. We can put that on the picture, over 3 and down 2 for a vertex. We've got something that opens to the what do we say? To the left from there. Focus, let's travel 5 units in the negative direction. So we're going horizontally 5 units. 3 minus 5 gives me -2 here. So -2, -2. 5 units this way. 1, 2, 3, 4, 5. Should be the focus. You can picture the parabola already. Now I am in the way, so this is kind of cool. I can just bounce myself up here, and now I've moved across the page. Did I put the focus on here? So this way, we'll put a focus there. And it's going to be a little bit wider and open to the left. You've got a directrix going the other way, so 5 units to the right. If we add 5 to 3, you get y equals 8. And 1, 2, 3, 4, 5. Maybe I should use the line tool. See, I'm getting the hang of this a little bit. You have a directrix that way. And you can put arrows on the end of that line. And axis of symmetry is going to be the next thing. So we got a directrix. And then axis of symmetry. What's the shared coordinate, right? They both have a y coordinate of -2. Y equals -2 is the easy way to get the axis of symmetry, and it's got to go straight through those points. So dotted line straight through those points. And the scary part, a parabola that's going to open to the left pretty widely. Oh my goodness. Oh my goodness. What a tragedy. Have it be a nice, smooth, non-pointed curve. And let's keep going from there. Okay, so these last two. Both of them, actually neither of them is technically in the standard form that we know and love. Our standard form has a coefficient always on the side with the non-squared variable. So if you want to multiply both sides by -12 right now, you can get number 3 to look like -12y equals x squared. And we can tell right now this is an x squared, so our choices are opening up or down. And let's pick down since we have a -4p value. So this thing is going to be a downward opening parabola. It gets to be a function as well with a vertex at the origin if h and k are both 0. It's going to open down from there. How far down? How far are you going to travel? Well, -12 is going to equal 4p. So p is equal to -3. And we have to go 3 units down to get to the focus. We'll put the focus here at 0, -3. Directrix, 3 units up the other way. I can use a line tool for this. Yeah, that should work well. We go 3 units that way. We put the arrows on the end of it. That looks fine. And what's the equation for that? Y equals 3. 3 units up. Am I aligned now? Oh, gee. Oh, that's cool because it still made the y because those are lines. And I think I can delete those so it doesn't look like 113. So y equals 3. Work in progress here. Is the directrix axis of symmetry? Look for the shared coordinate. X equals 0. Should be the axis of symmetry. Dotted line straight through all this stuff. And you can write the equation of that. You can draw a parabola. That actually looks a tiny bit better than the last one. So axis of symmetry, let's say x equals 0. We can call it a day on that one. One more. One move, we'll put this into standard form. Let's isolate the squared term. So just y squared equals 6x. Make yourself a little sketch. Is this parabola going to open up, down, left, or right? Did you say right? Because you knew it was going to be sideways with an x squared. And you know that 4p is equal to 6. So 4p equals 6. P is going to be reduced as 3 over 2, 1.5 units in the positive direction, so I'll have it open to the right. Expect this parabola to open in the positive direction. Vertex again, this one's 0, 0, x minus nothing, y minus nothing. Let me switch colors and put a red vertex here. Focus, we should be, try that one more time. Focus, we should be 3/2 of a unit in the rightward direction, so 1.5, 0 could be the focus, 1.5 units. So it's in a little bit closer. 1.5 units the other way at x equals -1.5. gets us the directrix. Use a line. Directrix. Just estimating that. And then axis of symmetry. Axis of symmetry, what's your shared coordinates? The y's. So y equals 0. And you got a dotted line straight through all, oh no, straight through all of those. Hope I'm not messing anything up. And then last but not least, don't forget to sketch the parabola, right? Have it open to the right. All right, next we're gonna go down and solve these three problems at the bottom, the ones where you're given info about the parabola and you have to write the standard form equation. Feel free to pause the video now. It might be a good idea to try these three on your own first and then come back and check your work with mine as we finish up the video. And I'm also going to use a sketch for all three of these. Just know that like with the other conic sections, you don't have to draw a sketch. If you're able to figure out the orientation of it without a sketch, that's totally fine. For the first one, you have a vertex up at 0, 4. So we'll put the vertex up here at 0, 4. Is this going to give me vertex there at 0, 4, and the directrix is down at y equals 2. My vertex went away. You know automatically the parabola has to open away from the directrix. So I know right now by this orientation, x is going to be squared in your standard form equation, and it's x minus 0 squared, right? There's no h there, equals 4p times y minus k, and here k is going to be 4, the y coordinate of the vertex. And now our missing link is P. Well, what do we know that could get us P? We know that the focus is 2 units up this way because the directrix was 2 units down that way. P has got to be positive 2. And we can leave this answer as x squared equals 4 times 2, so an 8, positive 8, times y minus 4. And that looks pretty good for standard form. Let's look at 6. 6, you're given a focus and a directrix. Okay, we should be able to do this one. Directrix at x equals 4, focus at 2, 5. Can I do that? 2, yeah, I knew that was going to be bad. 2, 5 is the focus. The directrix is at x equals 4. So x equals 4 is a vertical line, right? So we're going 4 that way. Can you tell right now that the parabola opens to the left? That's what I'm hoping. The vertex is right in between the focus and directrix, and I think there's 1 unit of space in between the vertex and the focus here. Vertex is going to be at 3, 5, and we know this thing opens away from the directrix to the left, so y is going to be squared. So y minus 5 squared equals 4p. We'll find out p in a second, and then x minus 3. And then to find P, you can look at the picture. It's the distance from vertex to focus. It's going to be -1. So instead of saying 4P in our final answer, we could put -4. And then that one's in standard form. For the last one, definitely plot the 2 points. I think the picture is really helpful for number 7. So passes through, yikes, passes through 2, -1. And vertex at -7, -5. I wonder why they had to give us the last piece of info. Vertex is here. Why did they say it? Why did they have to say it opens to the right? Can you think of any other possibility here? It opening to the right. Okay, yeah, opening to the right. I agree with that. I can see one parabola that opens that way. You could see another parabola that opens up and has this vertex. So it's good that they specified this is going to be sideways. It'll be a y minus k squared. And we know h and k from the coordinates of the vertex. So y minus -5, y plus 5 squared equals 4p. And then we'll say x minus h. So x minus -7 plus 7. Now you got to find P, and this is a classic. We've seen this with the other conic sections that passes through. I'm hoping you're thinking, let's plug the coordinates of the point in. We'll plug in -1 for y. We'll plug in positive 2 for x, so 2 plus 7. YouTube is going to cut me off after 15 minutes of this video, and I have less than a minute to go. So you'd solve this out. Do that on your own. You get P equals, to cut to the chase, we're going to say 4/9. And in your standard form equation, it's that times 4 is going to go there. So y plus 5 squared equals 4 times 4/9, 16/9. And then x, we'll say plus 7. So I apologize for rushing through that last question, but thanks for hanging in there with me. And I think I've come in just under 15 minutes. I hope you guys have a very nice day. Take note of parabolas that you see in your everyday lives and let me know what you come up with. All right, bye-bye.